Hi there and welcome. I'm Rebecca Weaver. We're going to be looking at section 9.2 today, integration by parts. So we need to write down what it is. The following equation is the principle of integration by parts and is one of the most important techniques of integration. So we're going to follow this particular rule here. It's the integral of a function times another function. So what we have to do is we have to look at what's f and what's g, and we get to select. And sometimes you'll choose one to be f and one to be g, and you'll realize, oh, I should have swapped it around because one will be easier than the other. So if what you're doing is not working, just start over and try to choose a different f and g. So this is going to be equal to just the plain f of x function times the antiderivative of g minus the integral of, now you'll take the derivative of your f and you'll put the antiderivative in there with that as well, and you'll multiply those for that integration where that capital G of x is your antiderivative. All right, so once again, let's start this show, and I went ahead and put our integration by parts formula on here so we could see what's happening. So we need for one of these to be f and one of them to be g. So you see we have an x here and we have a 2x minus 3 cubed. So what we're going to do is just set it up as f of x is equal to x, and we're going to let the g of x be the 2x minus 3 quantity cubed. So I'm going to need the derivative of my f, that's a 1. That's pretty nice. And then I'll need to do the antiderivative of g. That would be 1/8 times 2x minus 3, all raised to the 4th. So you'll have to do this every time. So you'll pick out your f, you'll pick out your g, take the derivative of one and the integral of the other, and be sure you know which one's f and which one's g. Then, when we put this into our formula, what we have left is x times with x, which is our f, and then we multiply it by that g, which was the antiderivative, 1/8 times 2x minus 3 raised to the 4th, minus, and then all we have left is integral of 1, which was my derivative of f, times that antiderivative of g with respect to x. So we'll just have this integral to do, which we can do with the techniques we've learned before. So let's look at this. What did we do? We said that we're going to perform this particular integration because this first term's already done. So we're going to do this integration using our other techniques. That would end up being minus 1/8 times 1/10. That has to do with this 5 and this 2. And then that would be 2x minus 3 quantity to the 5th plus c. And then simplifying that, we get this here, this 1/8x times 2x minus 3 to the 4th, minus that 1/80 times 2x minus 3, all raised to the 5th plus c. Let's do another one. So let's say that we have the integral of x squared e to the x. We're supposed to evaluate this. So we pick an f and we pick a g. So I've picked f, that will be x squared, and the derivative is 2x. Pick a g, that's e to the x. Ooh, and I like the integral of e to the x, it's just e to the x. So what we end up with when we put this into our formula for integration by parts is we end up with our f, which is x squared, times our antiderivative of g, which is e to the x, minus the integral of, next comes our derivative of f, which was 2x, times our antiderivative of g, and then take that integral with respect to x. So notice that that integral is not easy to solve. I have to do integration by parts again. So here we go. I'm going to choose another f and g with that integral, and my f in this last integral is going to be 2x. The derivative will be 2. And my g of x will be e to the x, and once again, the antiderivative e to the x. That makes me happy. Let's put all this together. Now I'm just doing that last integral here, and I'll write down into my integration by parts formula. So there's my f, there's my antiderivative of g, minus the integral of the derivative of f times the antiderivative of g, take that integral with respect to x. I can take this integral, it's really sweet, really nice, and I'll end up with that 2x e to the x minus 2e to the x plus c. Now let's put it all together because we got to put it all into our original form that we had here. So we're just replacing this last integral with what we just got. And so we end up as our answer as x squared e to the x minus 2x e to the x plus 2e to the x minus c. All right. So if you have any questions, email me, integration by parts. I'll have some Khan Academy videos up there for you too, so you can see more examples. Just remember that any of the trig examples, the sine, cosine, or tangent, Khan Academy might do those. You are not expected to do any of the trig. So, so if you see any sine, cosine, or tangent, any trig functions, you can just say, oh, I don't need to do those. And so kind of skip over those real quick. All right. Have a fabulous day. Bye now.